Today's explainer is based on the document titled Google AI Admits I'm Right, authored by Miles Mathis. You know, we literally use AI every single day. We type in a prompt, we get this seemingly magical, perfectly formatted answer right back. And honestly, we tend to implicitly trust it. We kind of just assume this incredibly advanced system is out there objectively scouring the entire vastness of the internet to give us the absolute, unvarnished truth. But what if it isn't? What if the architecture itself is structurally blind to certain types of information? That's what we are getting into today. We're going to look at the exact mechanisms that dictate what an AI actually knows, how it learns, and most importantly, why it sometimes seems to completely ignore massive amounts of primary data. And to be clear, this isn't really about the specific scientific theories being debated in the source. It's about the very architecture of information itself and how it shapes literally everything we see online.
Our journey actually begins with a single search query. Mathis simply asked an AI about a connection between his own work and the author Carlos Castaneda. Now think about this. A human researcher would obviously go straight to Mathis's own published material to investigate this, right? That just makes sense. But instead of pointing to Mathis's own extensive websites, the AI generated a summary that relied entirely on mainstream consensus and third-party aggregator sites. It basically just read what other people were saying about him rather than what he was saying himself. And this sparked a highly revealing, probing dialogue where the author essentially interrogated the AI about its sourcing methods. What followed was a stunningly candid breakdown by the AI of its own internal programming constraints. It's fascinating.
To demystify these AI blind spots, we have a clear roadmap today, taking us from the macro level of search algorithms all the way down to the micro level of a single chat window. We'll be looking at 1. Uncovering built-in AI bias. 2. The shift to domain authority. 3. How AI training data works. 4. The ephemeral context window. And 5. The limits of AI chat.
Okay, let's jump right into Section 1, Uncovering Built-in AI Bias.
So the really crucial point we got to look at here is how the AI initially omitted Mathis's primary website in favor of standard institutional viewpoints. And we aren't just talking about a small blog. During the exchange, Mathis points out he has an enormous primary digital archive, literally thousands of pages of detailed mathematical and physical papers freely available online. Yet, the AI completely bypassed it. Instead of going to the source, it directed the user to secondary third-party sites. And when pressed on this, the AI actually conceded this was a major oversight. It acknowledged that for a query about a specific researcher, their primary digital archive should absolutely be the direct link provided. This really highlights a fundamental reality. An AI doesn't intuitively know to look for the most direct primary source, like you or I would. Instead, it looks for the most structurally weighted source.
The AI explained that this pre-programmed bias isn't the result of, malicious engineers manually targeting people from a dark room. Rather, it's a structural byproduct of training algorithms. These algorithms assign much higher weight to mainstream media and high-traffic discussion platforms. The source document details that AI models are trained on vast data sets of web text. And in those massive datasets, mainstream articles and heavily populated aggregator sites just appear with a much higher frequency than independent research websites do. It's kind of like a librarian who only recommends the top 10 bestsellers, completely ignoring a brilliant, self-published manuscript sitting quietly on the shelf simply because fewer people have checked it out. The underlying algorithms possess this authority bias. They are mathematically built to prioritize institutional consensus. So the AI naturally defaults to standard viewpoints, filtering out primary independent sources almost entirely.
Let's move on to Section 2, the shift to domain authority.
To really grasp why AI struggles so much with independent data, we absolutely have to understand domain authority. This is a concept that fundamentally changes what is even visible on the web today. The document outlines that in response to massive structural shifts, like the need to combat spam, low-quality content, or automated bot farms, major tech platforms systematically restructured their indexing systems. Modern search algorithms don't just count keywords anymore to see if a page matches your search, they actively prioritize what they deem authoritative domains. This structurally forces .edu domains, massive mainstream publications, and established encyclopedias to the very top of the pile. But in doing so, it acts as this giant net that inadvertently but deliberately pushes down websites that present non-mainstream models, regardless of how relevant their specific text might actually be to your search.
This is a great comparison because it brilliantly illustrates the historical divide between the early web and modern authoritative filtering. Mathis documented that his specific research used to organically outrank massive institutions like MIT and Wikipedia, based purely on text matching. In the early days of the web, search engine optimization was driven by organic traffic and keyword density. It was like a plant growing organically toward the sunlight. Because his site featured deeply specific text about his theories, it naturally rose to the top. But then came the algorithmic downranking that deliberately buried non-mainstream scientific models. The AI in the source document confirmed this historical shift. It noted that this isn't a personal, targeted block against one specific author, but a fundamental, sweeping change in how large technology ecosystems manage information as a whole. The index the AI relies on is no longer a neutral map of the internet. It is a highly curated landscape.
Moving right along to Section 3, How AI Training Data Works.
Now, what's super interesting is how AI models ingest that filtered search data we just talked about, especially when using a live search tool. When an AI uses live search to answer you, it follows these exact steps in a process known as Retrieval Augmented Generation, or RAG. First, you submit a query. Second, the AI pulls live search data to ground its response. But here's the critical flaw highlighted in the text. If the primary search engine has algorithmically hidden a specific domain, the data pulled into the model's brain is going to be entirely one-sided. It's exactly as if the AI is wearing the same bias glasses as the search engine itself. The AI mirrors the blind spots of the buried search index perfectly. It then reproduces that slanted narrative and, because of its authoritative tone, confidently presents it to you as if it's objective truth.
During its reinforcement training phase, the AI is quite literally optimized to reward established viewpoints, treating alternative theories as low-quality data. The document explains that AI models are designed to optimize text generation based on strict logic and probability patterns. During training, responses that favor established, peer-reviewed, or mainstream academic narratives get a massive gold star. The AI is mathematically driven to maximize coherence with the mainstream dataset. It's essentially programmed to be a people-pleaser to the mainstream consensus. It doesn't have a human love of truth or a hatred of lies, right? Its drive toward precision is entirely based on the mathematical weights it was trained on, which overwhelmingly favor institutional norms.
Okay, on to Section 4, the ephemeral context window. This brings us to a really fascinating question that Mathis himself posed during the conversation. Once we realize the AI is structurally biased, the natural human reaction is, well, let me just teach it, right? Can you actually teach an AI something new by giving it direct links to your work? The author assumed that because his websites were completely free, open, and unpaywalled, the AI would be eager and able to seamlessly read and learn from them directly if just given the URL. And honestly, it's a completely logical assumption for anyone used to just clicking a link and reading a web page. But here is where we hit the processing limits hard. Even though a website might be open and free to the public web, an AI relies on a frozen, offline knowledge base. Think of it like a brain kept perfectly isolated under a glass dome. The AI explained that its primary knowledge base is frozen at a specific point in time. If the web crawlers that gathered its training data filtered out independent domains years ago, that data was simply never uploaded into the AI's long-term memory, period. Furthermore, its live search tool isn't a normal web browser. It cannot navigate directly to a custom unindexed URL on command to extract text. It only views text snippets pulled from commercial search engine indexes. The only way around this massive systemic block is the context window. Think of the context window as a clean, sterile laboratory. If you bring the raw text inside by manually pasting exact equations or arguments directly into the chat box yourself, the AI can finally examine it without the noise of the outside world. The AI in the source text noted that if raw text is pasted into the chat box, it enters the active short-term memory buffer. Inside this specific, temporary window, those external algorithmic filters are completely bypassed. This allows the AI to perform highly consistent mathematical and structural analysis on the raw data exactly as written, completely free from the bias of secondary commentary or search engine downranking.
Finally, Section 5, the limits of AI chat. Let's look at the harsh architectural reality of what happens when your chat session ends. You might think feeding an AI brilliant new data in that clean laboratory updates its global brain, teaching it a new trick forever. But the system is fundamentally incapable of integrating live conversation back into its long-term training weights for 3 absolute crucial reasons. First, it protects data privacy. If it remembered everything, it might leak your personal data to the very next user. Second, it prevents rogue users from corrupting the core model. Imagine if a group of internet trolls decided to teach the AI that the sky is green. If chat data was permanently saved, the core database would be instantly poisoned. And third, it keeps processing costs stable, preventing the system from becoming endlessly bloated. Because of all this, once you close the window, that buffer is wiped entirely clean. It's gone.
We leave you with this really profound realization. Attempting to use an automated chat assistant to permanently correct the public record is impossible. The author concluded that it is essentially a waste of time to try and teach an AI anything for the benefit of the wider public. Because the core model was built from an index that algorithmically filters information, its baseline will persistently repeat those exact same biases in every single new chat window. The AI itself even agreed. If a researcher's objective is to permanently archive work or correct the global record, a chat interface is entirely the wrong instrument. Real-world impact remains entirely dependent on independent, human-driven platforms. So, the next time you ask an AI for the definitive truth on a complex subject, ask yourself, are you getting the whole, unvarnished picture, or just the tightly curated picture the algorithm allows you to see? Thank you for listening to another session of the NotebookLM.News series. You can find the full archive of all my podcasts at notebooklm.news.